Hello everyone, hope all of you are doing great. And in today's video, we're going to have a look at fractions and recurring decimals. All right, so the first thing that we're going to learn today is how to convert fractions into decimals. This is a very old lesson that you actually took even in year six. So let's start with this. How can I convert a 2 over 5 into a decimal? The first thing, as all of you know, is that I need the denominator to be a 10 or 100 or 1,000. So making this a 10, I'm going to need to multiply it by 2 and up also by 2. So what is the new fraction going to be? 4 over 10, which is actually what as a decimal? 0.4. It is 4 tenths. So 4 tenths, how do you write it? 4 in the tenths place. The tenths place is the first digit after the decimal point. So 0.4, did it end? Yes, mister, it ended. I can do it over here. So it's just a 0.4 and it's not an endless decimal number. If it's not endless, what do we call it? We call it terminating. What do we call it? Terminating. What is the meaning of terminating? Not endless, it ends, which means it ends. All right. The next fraction over here, to make it into a decimal, I need to multiply this by 4, multiply this by 4 to give me 12 over 100, which is 12 hundredths, which means the last digit is in the hundredths place, 0.12. All right, and this is also terminating, which means the decimal ends. Terminating decimal. Good. Next one over here. If you multiply by 5 and here by 5, why? To make it 5 over 100, which is 0. Don't say 0.5. That would be a big mistake. It's 5 hundredths, which means 5 in the hundredths place. So it's 0.05, which is also terminating. All right. Now we're going to have a look at a different situation. If it is 1 over 9, Mr. I don't know what 9 times what is going to give me a 10 or 100 or 1,000. Actually, I don't know either. Yes, I'm a math teacher. I don't know 9 times what is going to give me a 10. 9 times what is going to give me 100 or 1,000. I don't know that. So what is the solution? The same thing over here with the 3. I don't know 3 times what is going to give me exactly a 10 or 100 or 1,000. So how can we do this? Division. 1 over 9 means 1 divided by 9. Let me choose a different color for this. 1 divided by 9. So how many 9s are in 1? 0. Oh, Mister, what am I going to do after that? Put point 0, the point up, and continue dividing. How many 9s are in 10? There is only one 9 in the 10, and I would have remainder 1. How many 9s are in 10? Also 1. Oh, okay. It's going to be endless, mister. So the 1 will keep repeating. So how can I write this? Am I supposed to write 0.1111? No. Just a dot notation above the 1. This means that the 1 is recurring, which means it is endless. So I'm going to go over there and write that 1 over 9 actually is equal to 0.1 with a dot notation above the 1. And this is what we call recurring decimal. Why? It has a repeating pattern. It's not only that it's endless, it doesn't end. No, it has also a repeating pattern. This is what we call recurring decimal. Next one, I'm going to do the same thing. I need to do 2 divided by 3. It's going to be 2.0. Put the point up. How many 3s are in 2? 0. But how many 3s are in 20? You're going to find that it is 6. Remainder 2. How many 3s are in 20? Oh, mister, it will keep repeating. So it's 0.6, a dot notation above the 6. And you're going to find that this is also recurring. So now we know how to convert any fraction into a decimal using a denominator of 10, 100, or 1,000, and using denominators that cannot be converted into a 10 or 100 or 1,000 by using the division. The division can be short division like what I've done over here, or long division. And we also learned the difference between terminating and recurring decimals. Let's have a look at another part of the lesson. Prime numbers. What are the prime numbers? Oh, Mister, what does this have to do with fractions and recurring decimals? You're going to see in a minute. I just want to remind you of prime numbers, and this is something that you took in year 5, actually. So here, examples of prime numbers. Prime numbers are numbers that have factors of only 1 and itself. Like what? Like 2. What are the factors of 2? The prime factors of 2, not the factors. The prime factors, sorry, the factors of 2, not the prime factors. The factors of 2 are only 1 and 2. You multiply 1 only by itself. 2 and 1. So what are the factors of 3? Only 1 and 3. What are the factors of 5? Only 1 and 5. What are the factors of 19? Only 1 and 19. You're not going to find anything else to multiply so that it gives you 19. Only 1 and 19. So that's why we call them prime numbers. Okay. What about the prime factors? Prime factors, if you remember, you took before the stick method or the factor tree. So if I want the prime factors of 12, I can do like that. And then what's the number, the prime number that I can divide 12 by? Don't say to me, I can divide it by 4. Oh, wrong. Why? I need a prime factor. It is a list of the prime factors. No composite numbers can be included in this. So it is 12 divided by what? Yes, you can say 12 divided by 2, which is 6, divided by 2, which is 3, divided by 3, which is 1. So what are the prime factors of 12? 2, 2, and 3. These are the prime factors of 12. 2, 2, 3. What about 36? 36. Let's do it with the factor tree. It is, Mister, is 3 times 12. And I got 12 here is 3 times 4. And I got the 4 is 2 times 2. I got a Mister, the 2, the 2, the 3, and the 3. That's it. These are the prime factors. So this is the stick method, and this is the factor tree. So now we know the prime factors, the prime numbers, and how to get the prime factors of a number. What does this have to do with our lesson today? Fractions and recurring decimals. We're going to go back to the lesson here. Look at this. This question comes a lot in exams, and you're going to find a lot also in the learner's book and the workbook. They say to you, how can I know if a fraction has a terminating or recurring decimal without any calculations? So without doing the division that we've done here in the first slide, without doing the division, how can you know if it has recurring or terminating decimal? Well, there is a trick actually, or a test that you must use to know if a fraction has a recurring or terminating decimal. What is it? If it has terminating decimal, then the denominator of the simplest form has prime factors of only 2, only 5, or 2 and 5. What does this mean, Mister? Look at this. What are the denominator? Is this first in the simplest form or not? That's the first thing that I need to check. Yes, it's in the simplest form. I cannot simplify more than that. I can divide the 8 by 2. I can divide the 3 by 3. Yes, but I need a number that I can divide both of them by. There is nothing, Mister, that I can divide both of them by. So it is already in the simplest form. Good. Let's continue. The denominator now. Here is the denominator of the simplest form, which is the 3. What are the prime factors of the 3? Does it have any prime factors other than 2 and 5? Or it's only 2 or 5 or 2 and 5? Well, Mister, it has actually prime factors of only 3. 3 is a prime number already. So it has, yeah, Mister, a prime factor of 3. So it is actually it has a recurring decimal. If it had only prime factors of 2, prime factors of 5, or prime factors of 2 and 5 together, then it is definitely terminating. Like what? Let's see in this example. 21 over 5. What are the prime factors of the denominator here? the prime factors of the denominator? Let's see. Here, it is only a Mr. 5. I have a 5. Well, so you have a prime factor of 5. Do you have anything else other than 2 or 5? No, it is only a 5. So it is terminating. Terminating. Let's go to this example. 28 over 9. What are the prime factors of 9? The denominator. Is it first in the simplest form or not? That's the first thing you must ask yourself. Yes, it is in the simplest form. So I have to continue. What are the prime factors of 9? Does it have any prime factors other than 2 or 5? Yes, it has prime factors of 3. So it is recurring decimal. It has prime factors other than 2 and 5. All right, let's go to the last example. The denominator here, the 12. Oh, mister, you forgot. I need to check first. Is it the simplest form or not? Well, it is not in the simplest form. This was going to be extremely important. It is extremely important. So I need to divide here by 3 and here by 3. What is the new fraction going to be? It's going to be here 13 over 4. Now I need to check the denominator. It is already now the simplest form. Check the denominator. The 4. Does it have prime factors other than 2 and 5? Well, the 4 has prime factors of only 2 times 2. So it's only 2. Yes. Yeah, but it is terminating. It is what? It is terminating. The prime factors of the denominator has only prime factors of 2 or 5. Only. Yes, mister, it's only 2. Thank you. Then it is definitely terminating. That's it, and see you in another video.